Working on a 2011 Buick Regal. It's got the 2.0 turbo LHU engine. We've got a few codes set here, but the ones I'm concerned about the most are the P0016 and P0017. I suspect needs a new timing chain, phasers, guides, everything's going to get replaced. I went ahead and bought all the parts. Bought the timing kit. It comes with everything, all the phasers, chains, guides, and the tensioners. I also bought the replacement parts for the chain that drives the balance shafts and the water pump, and replacement balance shaft gears. I got a new water pump, and it's also going to get a new oil pump. The oil pump is basically built into the front timing cover, so everything's going to get replaced. But before I do that, I want to get an oscilloscope capture. I want to look at the cam and crank correlation before and after, and these are the sensors that I want to probe. We're going to do 4 channels. We're going to do an ignition sync on cylinder number 1. We're going to do the crankshaft, intake cam position, and the exhaust cam position, and they should be on X3 connector, and it's this top connector on the ECU. And I verified it by matching up the colors on these pinouts. That black wire is 72, and these two are 52 and 72. And I matched up the color wires. None of them match on the other 2 connectors, the X1 and X2. This is the X3. So I'm going to get to work probing these. I'm just going to get some piercing probes, find the wires, and get the oscilloscope set up so I can get a capture on it. Okay, here's the crank and cam correlations. Taken with a Hantek, the 1008C 8-channel oscilloscope, but running 3 channels. Crank, intake cam, exhaust cam. I was going to run an ignition sync, but the more channels you run off of this Hantek, the less resolution you get. And as you can see, it's not all that great, but this is the best image I can get, running 20 milliseconds per division. Yeah, that's pretty good for what I want. I just want to reference where the cams are in reference to this crank. It's not as, the software isn't as good as like the Pico software or H-scope software, to where you can reference, you can put cursors 720 degrees, because from here to there 720 degrees, so you can actually measure in crankshaft degrees where these signals are in reference to the crank. And but this will be good enough. It's basically just for educational purposes for me, just to get familiarized with this oscilloscope testing. But yeah, it's pretty good for now. We'll go ahead and run with this. And I've got a few other images saved too. Fortunately, with this one, the buffer with the Hantek, the buffer isn't all that great, so you actually have to run the capture and stop it to where you get an image like that, to where you see 3 of these empty spots here, because that indicates 720 degrees there. I'm actually going to save this one so I can reference. One good thing about this is you can save these. Let's see, I'll save it into my waveforms folder. Let's see if it actually did save it. Yep, there it is. I've got several other ones. First ones I took had this interference here, So I took a few others just to get a nice clean signal. Doesn't really matter, but here's a nice clean one. So I have some picoscope captures that I can reference. I'm not going to be able to get the measurements on these. I guess I could. There's a way you can get measurements. You can load these up onto Paint, and you can actually measure the positions. So I think I might try that. That's kind of a workaround, because this software really doesn't have the automotive cursors for the 720 degrees. But there's always workarounds. And what I'll do is I'll just measure from one of these valleys right here, say from like right there all the way to here. That's 720 degrees, and I'll just measure, reference these to that. But it's pretty neat. I'll play around with this, see what I can figure out. Okay, I found out something real cool about this Hantek software, to where you can measure out time from one point to another and convert that into degrees. So like I said before, from this point to this point should be 720 degrees. And a way you can measure that, I'm sure there's other people that have figured this out, but this is new to me. You can go into Cursor and click Vertical, and you can choose your start point and measure. Let's see, if you measure from that point to that point, here's the time. It's 121 milliseconds down here. And if you take that and convert it, you can, so 720 degrees equals 121 milliseconds. You divide 121 by 720, and you get that number. So that equals 1 degree of crankshaft rotation. For example, 10 degrees equals that number times 10, and 10 degrees of crankshaft rotation should equal that in milliseconds. So I have a known good waveform here. This is off of Picoscope, and originally it was throwing me off because this pump right here, originally I had my scope set up to where the intake was down here and the exhaust. You could see this is channel 2. Originally I had crank for channel 1, and I had number 2 right above it, and that was the intake, or that's how I had it wired up. And then the exhaust, number 3, was up here. But this is the other way around. This is the exhaust, and that's the intake. And I did some digging around, and originally I watched a video from South Main Auto, and Eric O had these two captures. This is a known good one, and this is the one that he took. And it was throwing me off too, because he had green and red up here, and it was switched over. But he stated in the video that he just had the colors opposite. And this is a known good. You could see this hump right here, and that's on the exhaust cam. And that's why it was throwing me off, because I was trying to match the humps, and this one is really close to that edge right there, just like on this one, but it's a little bit retarded. This is advanced, and this way is retarded. So this is the known good position, and you can see his was advanced, and he was able to, I think it was the code setting criteria for the P0016 and the P0017 is if the cams are off 10 degrees, it'll throw the code. And he was able to verify in degrees that his were advanced past the code setting threshold. And so I wanted to figure out a way to where I can measure, and I came up with this solution here. And so from here to there is the 720 degrees, and I did the conversion. And on this known good, this is off of a 2011 Buick Regal 2.0, same one that I'm working on, and they're similar on the actually. Erico from South Main Auto, he was working on a 2.4, and the waveforms are exactly the same. And so on this one, they measured from here, from this edge right here of the crank signal to there is 136 degrees, and from here to this hump over here, this is the intake cam, should be 77.25 degrees. And I could do a quick measurement here. From there to there should be 24.8 milliseconds. And that's for the exhaust cam. And I did the math here, 24.8 milliseconds equals 147.57 degrees, and it's supposed to be 136, so that is advanced 11.57, so that passes the threshold on that for the code setting criteria. And on the intake, from there to there is supposed to be 77.25 degrees, and what I measured was 15.3 milliseconds, which translates into 91.04 degrees, and it's supposed to be 77.25, so that gives us an advance of 13.79 degrees. All right, oscilloscope diagnosis confirmed. Look at all that slack. We got problems, and that guide's missing. Okay, this is the post-repair waveform. Got the crank, exhaust, intake. Looks a lot better. This is the reference where I'm lining it up to the crank signal. Got everything all wrapped up. Running good, no codes, no leaks. I've got the two solenoids disconnected for the waveform capture, so it doesn't show any advance. We'll take this inside and do some measurements and see where everything is. All right, we got the post-repair waveform, and one thing I want to do is I want to measure to verify we've got the same measurements as before. From there to there, should it be 121 milliseconds? And it does check out. So next, I want to measure from here to there, to that section of the, that's the exhaust cam. Showing 22.2 milliseconds. And 168 microseconds equals 1 degree of rotation. So we've got 22.2 divided by 168 microseconds. We're showing 132 degrees, and on our known good, it's supposed to be 136. I'm not too sure if this is 100% accurate, but it's definitely an improvement. Before we were advanced, we were showing 147 degrees on the exhaust, and that gave us 11.57 degrees advanced from where we needed to be, so I think we're good there. Next one, we'll measure the intake cam from that point to this point, showing 12.9 milliseconds. 12.9 milliseconds divided by 168 microseconds. 76.78, almost 77 degrees advance. And we're supposed to be at 77.25, so it's pretty close. I'm not too sure how accurate this is supposed to be a known good for a 2.0 turbo 2011 Buick Regal, but I don't know how they came up with those measurements. They're using Pico software, so it might have been slightly different, the time measurements. So but I'm pretty happy with that. Everything turned out good. Fired right up, no leaks, no code set. I disconnected the VVT solenoids, oil control solenoids, so that it wouldn't have any advance, so I can get a accurate capture. And only other issues, I broke the connector off of the water coolant sensor, so I had to run to the salvage yard, get another connector, and I depinned it because I didn't want to make any splices, so just switched over the pins, and it was setting the code for that, but I cleared it out, and no DTCs, so we're good to go. Alright, here's a bonus video. Just trying to see if I can capture the cam and crank with this DS212, my little pocket 2-channel scope. And that's the crank and the exhaust cam. I was able to capture it with the stop recording button. But as you can see, you can set up cursors and measure the time. We got T1 and T2 post. So if you select that, this wheel, you can move it, and just like with the previous capture, I'm measuring from. Let's see if I can see that better. Measuring from that point to this point. So that's T2, T1, I don't think I have this T2 right spot. As you can see, we're measuring the same distance as we did with the Hantek scope, 22.2 milliseconds. So if we take 22.2 divided by 168 microseconds, we come up with the same number, 132 degrees. So it's possible. It's a little difficult with this little small scope because you can't really capture a whole lot on the screen. 5 milliseconds was the best capture I can get on this screen.